This is Newton's law of gravitation, but arguably it could be called Hooke's law of gravitation. Robert Hooke and Isaac Newton were both scientists and members of the Royal Society of London for Improving Natural Knowledge. During the 1670s, while there, they did not like one another. They hated each other, in fact. The first paper that Isaac Newton published at the Society was on optics. Hooke criticized this paper and it infuriated Newton. Then the second paper that Isaac Newton wrote while at the Society was on the properties of light. And in this paper, in this instance, Hooke actually criticized Isaac Newton of stealing data from him, of stealing content and plagiarizing his work. This infuriated Newton, and by this time they were mortal enemies. In 1678, Robert Hooke actually stated the inverse square law and the elliptical orbits that resulted. But it was determined that he didn't arrive at his result rigorously, okay? That he didn't use Kepler's third law and he didn't use concepts of central force, to arrive at his result. Sir Edmund Halley, okay, so we've all heard of Halley's Comet. Well, it's actually Halley's Comet because it's H-A-L-L-E-Y, so Hall-E. So Halley arrived at the Society in 1678, right? He immediately hooked up with Hooke, and they started working on the celestial body problem. They were trying to arrive at the result through those rigorous quantitative methods with Kepler's third law and also with the central force concepts. But they were unable to do so, and they had great difficulty. There was even a prize offered by Christopher Wren, the founder of the Society, to arrive at this result rigorously. But they couldn't do it. And Halley wanted to approach Newton with it. Hooke was, of course, opposed to this, but Halley went anyway. He said, look, here, and he asked Isaac Newton, this is the way that the legend goes. He says, Sir Isaac, what would be the path of the celestial path of a body if the force varied inversely with the square of the distance? And Isaac Newton, because he was so mathematically talented, the way the legend goes, is that, it would be an ellipse, right? Okay. Well, he had actually been sent a letter several years earlier by Hooke stating just that there would be an inverse square law with elliptical paths resulting, but again, not arrived at rigorously, but rather through an intuition of his, okay? So Halley encouraged Newton and pushed him to publish this, right? To work out the details and to publish it. And Halley even paid to have it done. So the Royal Society didn't have the money. Halley wanted to have it done, so the Society says, oh, well, you know what? You want this so bad? You pay for it. You pay to have it published. And so he paid the printing cost for Isaac Newton's Principia to be published. The work that resulted was called the Mathematical Principles of Natural Philosophy. You've heard it called the Principia before in short, so the Principia Mathematica in the Latin. So anyway, Hooke stated it first, and then it was just determined that he didn't arrive at this result rigorously, and so Isaac Newton was given the credit. See you next time.